We don't know if it's true that diamonds are a girl's best friend, but they are definitely Earth's best friend. Earth has been collecting diamonds from space for millions of years. In fact, some scientists think that diamonds bigger than grizzly bears could be raining down on us from space right now. These interstellar ice cubes are made of pure crystallized carbon. They're humongous, hot and hard, but what's most important is that they're extremely rare. Even though diamonds are quite common here on Earth, they're incredibly rare in space. That's because conditions that are required to form diamonds just aren't super common out there. So when these rare gems do make it to Earth, we should consider ourselves lucky. But before they can fall into our mines or end up in someone's jewelry box, they have to survive a fiery plunge through Earth's atmosphere. This journey is often accompanied by a bright flash and a long tail, which makes it look like the diamond is on fire. And in a way, it kind of is. But what exactly is going on during this plunge, and where do these sparkly space rocks come from in the first place? Let's dive into this sparkly mystery. First off, let's clear up some confusion over the term shooting star. Shooting stars aren't actually stars at all. The name comes from old-fashioned descriptions of these space rocks streaking through the night sky like a literal shooting star. But even though we call them shooting stars, these space rocks are actually meteors or meteorites. A meteoroid is a small, rocky or metallic object in outer space. It becomes a meteor when it enters Earth's atmosphere, and it becomes a meteorite once it lands on Earth. So how do these space rocks get up into Earth's atmosphere in the first place? Well, most of them come from two places. Some are leftovers from the formation of Earth, while others come from farther away. For example, they might originate from asteroids, which are rocky bodies that orbit the Sun. Or they could be bits of debris left over from comets, which are icy bodies that also orbit the Sun. Sometimes asteroids and comets get a little too close to Earth and bits break off. Other times, Earth's gravity messes with their orbits and knocks pieces off of them. And once these pieces break off, they enter Earth's atmosphere and start falling. And don't worry about the big rocks. Even if an asteroid the size of a house falls toward Earth, it'll probably break up before it hits us. Earth's gravity just has a funny way of doing that. Not only does gravity rip apart these space rocks, but it also gives them some serious speed. Most meteors hurtle toward Earth at speeds between 11 and 72 kilometers per second. At that speed, they can cover the distance between you and your best friend in less than 1/10 of a second. That's faster than Usain Bolt, who covers 100 meters in about 10 seconds. These space rocks are basically rocketing toward Earth. As they plummet toward the surface, they encounter tons of gas molecules. All the air in Earth's atmosphere weighs about 4.9 quadrillion metric tons, and as the meteor flies through all those molecules, it collides with them. At first, the friction between the meteor and the atmosphere causes the space rock to glow. Scientists call this process ablation. It's the same process that creates the glowing tails of comets. The difference is that a comet's tail is made of gas and dust being blown away by the solar wind. A meteor's tail, on the other hand, is made of the space rock itself. As the rock heats up, it loses mass, which makes its tail. To understand what happens next, we have to think about what the meteor is made of. If it's mostly iron and nickel like a typical asteroid, it'll burn up pretty quickly. As soon as it enters the atmosphere, the intense heat causes the metal to react with oxygen. It makes a bunch of new compounds and releases a ton of energy. This energy makes the meteor's glow even brighter and its tail longer. Eventually, it burns up completely. And if it started out small enough, this is where its journey ends. Smaller space rocks usually burn up before they even reach the ground. But if the meteor is made of something else, like a diamond, things will be a little different. Diamonds are pure crystallized carbon, which means they're super strong. They can withstand intense pressure and heat, which they experience a lot of when they're deep inside Earth. So when a diamond reaches the surface, it's already had practice surviving intense heat. In fact, diamonds can withstand temperatures as high as 700 degrees Celsius. And since meteors can get even hotter than that, a diamond won't even need to change chemical composition to survive the heat. Instead, it'll just need to keep its shape. Of course, even though diamonds are tough, they don't last forever. Eventually, the friction with Earth's atmosphere carves little pieces off the diamond and scatters them everywhere. The little pieces are called soot, and they create the long, bright tail that we associate with shooting stars. Unlike regular meteors, which burn up in the process, the soot from a diamond just drifts down to Earth as plain old dust. But sometimes we get lucky and find the dust in a really impressive shape. For example, in 2016, a space rock entered Earth's atmosphere and left behind a bright yellow trail. The rock was only about half a meter wide, but it glowed so brightly that people saw it from Argentina all the way up to Oregon. It even left behind a thin trail of dust 24 kilometers above Earth's surface, and after streaking across the sky for 17 minutes, it landed near the town of Puerto Williams in Chile. The rock turned out to be a diamond, a huge diamond. This interstellar ice cube weighed more than 18 kilograms and contained billions of carats of pure carbon. To put that in perspective, the world's largest diamond, the Cullinan diamond, only weighs about 3/100 carats, and the space rock that fell in Chile was 10 million times bigger than that. But the rock wasn't just any ordinary diamond. It was a graphite-coated diamond. Graphite is a form of carbon that's made of layers of atoms bonded together. Because it's made of so many layers, it's soft and slippery, which is why we use graphite to make pencils. Usually, graphite does not stay on diamonds for very long because it's not particularly stable under the high pressure and heat deep inside Earth. But this diamond somehow managed to keep its graphite coating all the way from outer space to the surface of Earth. It's a real gem of a mystery. And to solve it, scientists traveled to the small Chilean town where the diamond landed. They went to a field called Caverna del Diablo, which translates to Devil's Cavern. And here's where the story takes a strange turn. The team found some burnt grass and melted rock where the diamond landed, but no diamond. There were also some shiny black pieces of soot around the landing site, but they were humongous. I mean, they looked more like charcoal briquettes than sparkling dust. Where could the diamond be? The team continued searching and eventually found another piece of graphite-coated diamond about 40 centimeters away from the landing site. But this diamond wasn't just humongous. It was also totally ordinary. It didn't have any of the special properties that would make it valuable to geologists or geochemists, and this posed a big question. What happened to the rest of the diamond? Was it destroyed? Did aliens take it, or did someone steal it? The answer to this mystery lies somewhere between science and society. Here on Earth, we love our shiny rocks. We've mined diamonds for thousands of years, and we'll probably keep mining them for thousands more. They're used in tools, jewelry, and even military equipment. But we humans also love stories. When a meteorite falls to Earth, we tell stories about it. Sometimes those stories are based on science, and sometimes they're not. For example, people believe that meteorites can cure illnesses, grant wishes, or even cause bad luck. Because of these beliefs, people sometimes try to steal meteorites. There have been a lot of meteorite heists throughout history. People have stolen them from museums, research labs, and even each other's hands. So if a giant diamond meteorite fell from the sky, it'd be pretty easy for someone to snatch it and sell it to a shady buyer. Unfortunately, that's probably what happened to most of the giant diamond meteorite. Someone took it and sold it without telling anyone. But maybe it's okay. Maybe the laws of physics are better suited for explaining the universe than explaining human behavior. After all, we don't know exactly where all the pieces of the giant diamond ended up. But we do know that a couple pieces made it into the hands of scientists. Researchers think that this diamond is the purest that they've ever seen, and they think that it came from a dwarf planet that got smashed by a large asteroid early in Earth's history. Basically, this diamond is a time capsule that contains clues about the early days of our solar system. We might even use it to learn more about the formation of Earth and its big bestie, the Moon. So maybe it's okay that we don't know where all the pieces ended up. After all, we already got one pretty great thing out of it.